New research is illuminating the remarkable ways in which the gut communicates with the brain, showing that high-fiber diets can actively strengthen the gut's so-called second brain and support cognitive health. Far from being passive digestive organs, the gut and its resident microbes engage in complex signaling with the central nervous system via the vagus nerve, influencing mood, memory, and neuroplasticity. Recent studies reveal that fermentable fibers, found in foods like legumes, oats, green bananas, leafy greens, and cooked and cooled starchy vegetables, can enhance these neural pathways, promoting synaptic plasticity and strengthening the bidirectional communication between gut and brain. These findings are particularly exciting because they suggest that everyday dietary choices can have direct, mechanistic effects on brain function and resilience. At the heart of this connection is the vagus nerve, a major conduit linking the gut to the brainstem and higher cortical areas. Fermentable fibers are metabolized by gut bacteria into short-chain fatty acids, SCFAs, such as butyrate, acetate, and propionate. These SCFAs not only reduce local and systemic inflammation but also act as signaling molecules that influence vagal afferent neurons. By enhancing vagus nerve signaling, high-fiber diets improve communication between the gut and central nervous system, which in turn supports synaptic plasticity, the ability of neurons to form new connections, strengthen existing ones, and adapt to new information. Stronger synaptic plasticity underlies better learning, memory retention, and cognitive flexibility, providing a mechanistic explanation for the memory and mood benefits observed in high-fiber interventions. Animal studies provide clear evidence of this effect. Mice fed high-fiber diets demonstrate increased vagus nerve activity, higher levels of SCFA production, and improved performance in maze navigation and object recognition tasks, which are standard measures of memory and learning. Researchers have also observed enhanced expression of synaptic proteins and neurotrophic factors such as BDNF, brain-derived neurotrophic factor, which is critical for neuron survival, dendritic growth, and synaptic remodeling. In humans, observational and interventional studies are beginning to reflect similar patterns. Adults consuming fiber-rich diets tend to show improved attention, verbal memory, and even mood regulation, with emerging evidence suggesting that these cognitive benefits correlate with markers of enhanced vagus nerve activity and microbial diversity. Mechanistically, the effects extend beyond SCFAs. Certain fiber-fermenting microbes produce neurotransmitter precursors, including GABA and serotonin, which influence neural excitability and emotional regulation. By creating an environment rich in these neuroactive metabolites, high-fiber diets help maintain neural network stability, reduce stress-related disruptions in cognition, and enhance the brain's adaptive capacity. This illustrates the gut-brain axis not merely as a passive conduit, but as a dynamic system in which diet, microbes, and neural pathways coalesce to promote cognitive vitality. The practical implications of these findings are particularly encouraging. Fiber-rich foods are accessible, affordable, and easily integrated into daily meals. Legumes, oats, vegetables, fruits, and certain cooked and cooled starches can be consumed in a variety of forms: soups, salads, stews, or breakfast bowls, offering a simple, everyday intervention to strengthen gut-brain communication. By intentionally including these foods in regular dietary patterns, individuals can actively support vagus nerve function, reinforce synaptic plasticity, and improve memory, focus, and emotional resilience. Moreover, these findings dovetail with lifestyle strategies known to enhance cognitive function. Regular exercise, sufficient sleep, stress reduction, and mental engagement all synergize with a fiber-rich diet to optimize vagus nerve signaling and neuroplasticity. Together, these factors create a holistic approach in which dietary and behavioral interventions reinforce one another, promoting both gut and brain health. The emerging science underscores that cognitive resilience is modifiable. The brain's capacity to adapt and maintain function depends in part on the signals it receives from the gut, signals that can be enhanced through intentional nutrition and lifestyle choices. Beyond individual benefits, this research highlights a broader public health opportunity. Age-related cognitive decline and mood disorders are rising globally, and interventions that are low-cost, non-invasive, and widely accessible are particularly valuable. Encouraging fiber-rich diets not only improves digestive health, but may also contribute to population-level cognitive resilience, emotional well-being, and reduced risk of neurodegenerative conditions. Educational campaigns, community nutrition programs, and clinical guidance can all leverage these insights, empowering individuals to take proactive steps in maintaining cognitive vitality. In conclusion, new evidence underscores the powerful role of the gut as a second brain, with high-fiber diets strengthening vagus nerve signaling, enhancing synaptic plasticity, and supporting memory, attention, and emotional resilience. By providing nourishment to beneficial gut microbes and stimulating neuroactive metabolite production, fermentable fibers create a direct mechanistic link between diet and brain function. The message is both empowering and practical. By choosing fiber-rich foods consistently, individuals can actively cultivate gut-brain communication, bolster neuronal adaptability, and promote lifelong cognitive health, demonstrating that the path to sharper memory and mental agility may begin right on the plate.